Problem number 21. Find the smallest positive integer x such that 3x squared plus x equal to 4y squared plus y for some positive integer y. Okay, so because we want to solve this, we have 3x squared plus x and equal to 4y squared plus y. If we take y to left hand side, and then we have x minus y. We have 3x squared. If we take 3y squared to left hand side, then what is left? Y squared. Why I've done 3y squared? Because then the coefficients are equal. I can say this one is 3x squared minus y squared, which equal 3x minus y, x plus y, plus x minus y, equal to what? Y squared. Look, for each problem we can solve it for example general, but I want you to teach how we can solve with basic ideas with the things. Also we can solve IMO problems with these ideas. Fine, considering a small example, because 2 days exactly before the exam I released a video and I said if you check small example you can find the idea, not find the pattern of numbers. Then it helps you. We want to solve exactly with the idea of the video I released 2 days before the exam. So 3y plus 1 equal to y squared. Okay, so here we know it is positive, this one, so it should be also positive. So x is greater than equal y plus 1. So if you want to solve this, for example, you can check some small example. We can say what? We can say if y equal to 1, then x minus 1, then 3x plus 4 equal to 1, and we see it is impossible because it is x is at least 1. So you can check some numbers and you can see many things. For example, one thing is what? The parity of this term, because sign is not important, and here 3. The parity of this term and this term is equal. So the parity of this term and this term is not equal. It means one of them is odd, one of them is even. Why? It is an important rule in congruency. For example, x minus y, because minus a mod 2 is a. So sign is not important. So x minus y is congruent to x plus y, and we can multiply by 3, because 3 and 2 are coprime numbers, mod 2. So here you can say one of them even, always one of them odd. Or the students don't know congruency, you can check different cases of x, y, odd, even, and you see one of them odd, even. So we can conclude one of them is odd, one of them even, so y squared is even. So we conclude y is even. So for example, when you want to check a small example, you will see, okay, when y is 1, a parity is not same. So for example, if x is odd, it is even. If x is even, it is even. 1 is impossible. So y is even, we only need to check y that are even numbers. Then we can say what? We can say, okay, so x minus y, we want, for example, for each y, we want the minimum x. The problem says find minimum x. So for example, if x equal to y plus 1, then what happens? So this will be 1. This will be what? 3x will be 3y plus 3, 3y. So it will be 6y. Or if I write 1 times 3x will be 3y plus 1 plus 3y plus 1 equal y squared. Now here it will be what? 3y, 3y, 6y plus 3 plus 1, 4 equal to y squared. And then we can say, okay, it is greater than 6y. So if you divide by y, y is greater than 6, but y divides this term, so y divides 4. Y is a positive and contradiction because a number greater than 6 is not a divisor of 4. So we reach contradiction for this case. Now, so we are checking, for example, x, y plus 1 to understand the idea of the problem. If x equal y plus 2, then what we have? Their difference will be 2, and then 3y plus 2 plus 3y plus 1, which equals y squared. Now, here we say what? It is 2 times 6y plus 6 plus 1, 7 equal y squared. And we can say it is greater than what? 2 times 6, okay, 12y So we can say y is greater than 12. And now we can say what? We can say, okay, the right side we say y is even. So it is right side multiple of 4 because it is square. But on left side it is an odd number times 2. It is not multiple of 4. So if you cancel mod 4, we've reached contradiction. For next one, if x equals y plus 3, then our main equation is what? 3 times 3y plus 3 plus 3y plus 1 equal y squared. And it will be 3y, 3y, 6y plus 9 plus 110 equal y squared is greater than 18y. So y is greater than 18. And now we know y divides this. Y, it is what? 18y plus 30. We can check again divisibility, or you can say again right side is multiple of 4 and left side it is even. Okay, so maybe it's multiple of 4. Okay, here y divides this term, y divides 3 to 18y, so y divides 30. So the only divisor of 30 is y that's greater than 18 is y equal to 30. And if you replace y with 30, then it will be 3. 6 times 1, 180 plus then 190. And it is equal to 30 squared. The left side multiple of 19, the right side is not multiple of 19. Now, if we check x equal to y plus 4, then if we replace here, it will be 4 times 3y plus 4 plus 3y plus 1 equal to y squared. So here it will be 4, 3y, 3y, 6y plus 12 plus 1 plus 13 equal to y squared. So y divides 24y divides this, so y divides 4 times 13. And we can say it is greater than 24y. So if you divide by y, y is greater than 24. Y is even, so the only possible cases for y is when y equal greater than 24 and divisor of this. The only possible cases are 24 and 52. Because the problem says find minimum x. So at first we check 26. So if we check 26, then we have what? 4 times 6 times 26 plus 13. We want to check, is it possible? 26 squared. 26 squared is what? 2 times 13 squared. It is 4 times 13 squared. If we divide both sides by 4, then we will have what? We have these things. If we divide both sides by 13, then we have, it is what? 2 times 13. 6 times 2, 12 plus 1. Is it equal to 13? Yes, we see equal. So we found one answer. Y equal 26 and x equal 30. So we've checked until x equal to y plus 4. Now we say, okay, maybe for the other cases we can find minimum x. But if we check for the other case is x is at least y plus 5. Why? Because we said here it is positive. The problem says y and x are positive, positive, positive. It is positive. So x minus y is positive. We check this one for 1, 2, 3, and 4. So the other cases are it is greater than equal 5. So if x is greater than equal 5, then we can say here left hand side of this equation x minus 5, 1 is 5 times x is greater than, okay, so let's write greater than equal x with y plus 5 plus 3y plus 1. And we know left hand side equal right hand side equal y squared. So we can say y squared is greater than equal 5 times 3y plus 3y, 6y plus 15 plus 1, 16. So we can say what? We can say it is greater than 30y. So if we divide both sides by y, y is greater than 30. So x is greater than equal y plus 5. So x is greater than equal 35, or because we can say greater than equal y plus 5, and it is strictly greater than 30 plus 5, 35. So because of problem says find minimum x, we've proved that the minimum answer here is when x equal to 30. Okay, if you saw my video before the exam, I said, considering small examples, for example, here, we've considered is 1, 2, 3. We found a very basic solutions. Also, it has other solutions for large numbers. But for this number, you should learn this. And this idea works up to IMO, international level. Again, for round 2 also, I will release some solutions, some ideas. You can use them to improve your problem solving. So keep in touch, and thanks for your support and for watching the video. Please don't forget to subscribe and turn on notification.